If alpha and beta are the roots of this quadratic equation in Z, where iota is root over -1, then we need to find the value of this expression 16 into real part of this complex number alpha raised to 19 plus beta raised to 19 plus alpha raised to 11 plus beta raised to 11, and that divided by alpha raised to 15 plus beta raised to 15. The second term is also same, but here we need imaginary part of that complex number. Here we need real part. Now for this equation, the roots are alpha and beta. First, we need to simplify this expression, and then we'll see what are the real and imaginary parts of this one. So for a moment, let us say that this complex number is omega, right? This complex number alpha raised to 19 plus beta raised to 19 plus alpha raised to 11 plus beta raised to 11, and that divided by alpha raised to 15 plus beta raised to 15. Let us call this complex number as omega. So we have to think that how we can simplify this one. And remember, alpha is the root of this quadratic. So alpha will satisfy this quadratic equation, right? Now see here what we can do is that in denominator you have alpha raised to 15 plus beta raised to 15. So try to create the same thing in numerator. From these two terms, alpha raised to 19 and alpha raised to 11, you can take alpha raised to 15 common, and that means we have alpha raised to 4 plus 1 by alpha raised to 4. We'll see how to find the value of this one. And similarly, from the remaining two terms, you can take beta raised to 15 common, and that means you have beta raised to 4 plus 1 by beta raised to 4. This will be the numerator part of this complex number omega, and that divided by, in denominator, we have alpha raised to 15 plus beta raised to 15. This is the complex number omega, right? And now, because it is given that alpha is the root of this quadratic equation, so we'll try to find the value of alpha raised to 4 plus 1 by alpha raised to 4. And same thing we can do for beta also. So if alpha is the root of that given quadratic equation, we can say that 2 alpha square minus 3 alpha minus 2 iota, this will be 0. In place of z, we can substitute alpha because alpha is the root of this equation. And now we have to think that how we can create this term alpha raised to 4 plus 1 by alpha raised to 4. So for that, take this 3 alpha on other side. So that means 2 alpha square minus 2 iota. This will be 3 alpha. Now divide everything by alpha and also take 2 common. So then it becomes alpha minus iota by alpha, and this will be 3 by 2. We have divided by alpha on both sides, and we have also, when we have divided everything by 2 alpha, right? So this is what we are getting. And now we can square. The reason we are writing in this form is because if I use a minus b square formula, then in twice ab term alpha and 1 by alpha, this will cancel. So we'll get alpha square plus 1 by alpha square or minus 1 by alpha square, and then after one more square we can create this term. So if I square this one, we'll get alpha raised to 4, and then iota square by alpha square. Iota square is minus 1, so minus 1 by alpha square, and then minus twice ab. Now in minus twice ab term, alpha will cancel, and on right hand side we have 9 by 4. So this is what we are getting for alpha square minus 1 by alpha square. Now the same relation you can write as alpha square minus 1 by alpha square. This equals to 9 by 4 plus 2 iota. And we can square one more time to get the value of alpha raised to 4 plus 1 by alpha raised to 4. If I square this one, we'll get alpha raised to 4, 1 by alpha raised to 4 minus 2. And the right hand side will be 81 by 16 minus 4. And then the twice AB term will have 4 will cancel, so I think we'll get 9 iota from here, right? This will be the twice AB term, 2 into 2 iota into 9 by 4. So finally the value of alpha raised to 4 plus 1 by alpha raised to 4, this will be 81 by 16 minus 2. So 81 minus 32, that will be 49 by 16 plus 9 iota. So this is the value of alpha raised to 4 plus 1 by alpha raised to 4. Now remember, beta is also the root of same equation. So for beta raised to 4 plus 1 by beta raised to 4 also will have the same value. And that means this complex number, now you can write this complex number omega as I mean, these two will have same value, because I mean you can replace alpha with beta and then do the same sequence of steps. So beta raised to 4 plus 1 by beta raised to 4, that will also have the same value. So that you can take common. So then we are left with alpha raised to 15 plus beta raised to 15, and this multiplied by 49 by 16 plus 9 iota, because alpha and beta were the roots of same equation, so there will be same relation in terms of beta also. And this divided by alpha raised to 15 plus beta raised to 15. Now these two terms you can cancel. So ultimately omega is 49 by 16 plus 9 iota. And now the problem is we have to find the value of 16 into real part of this complex number multiplied by imaginary part. So for this problem, the answer will be 16 into real part is 49 by 16 and then imaginary part is 9. Now 49 into 9, so this will be 21 square, which is 441, right? So the correct answer for this problem will be first option. So this was a problem where, I mean, it was important to take alpha raised to 15 and beta raised to 15 common. And then from the given equation, first we need to calculate alpha square minus 1 by alpha square. And then again you have to square that one to create this term alpha raised to 4 plus beta raised to 4. Once we had values of this term, then we calculated omega. Omega was 49 by 16 plus 9 iota. So real part will be 49 by 16, imaginary part will be 9. After calculation, we'll get 441, and hence the correct answer for this problem will be first option.